with Android 11 for machine learning are focused on on-device ML due to the benefits which we talked about. The new MLKit now has better usability for on-device ML. And we'll see how it all works out, how you can actually use on-device ML with the new MLKit. The MLKit image classification and object detection and tracking models now also support custom models. What this means is you can have just a TensorFlow Lite model which runs on top of the state-of-the-art pre-existing models by MLKit. So I can have just a TensorFlow Lite model which runs on top of the state-of-the-art pre-existing models and gives me better customizability. So what this also means is what I really want to highlight over here is if you're working on some generic kind of use case. So let me give you an example. If you're working on image classification, a specific kind of image classification, let's say I'm working on image classification with, oh, I cannot come up with good. Okay. Yeah. One good example I came across, let's say you're working on humans versus horses. Just an example, you could do pretty much any kind, you could take up pretty much anything. Machine learning folks here might be, oh, I have heard humans versus horses somewhere. Yeah, it's open source data set, pretty famous. I just reference it over here. So yeah, let's say you're working on horses versus humans, object detection, which is a kind of generic use case. So what you can do is you can use the MLKit object detection models and run your own TFLite model on top of it. So if you're working on these kind of generic use cases or a specific kind of object detection, what I just showed an example to you, MLKit is the best thing to use. You should definitely be using MLKit. So let's actually see how you put this into practice and how you can start using it. So again, this is well applicable to all other models. This is well applicable to your own model, but I like to build something so we can build something while I give this talk. So what I'm making over here is a food classifier application. So you just show some food to the camera and it should be able to classify it. So I'll first start off by setting the model file, the TFLite model file. So a note over here, a lot of you might have already kind of guessed this, but you can see I have a .set asset file path. So yeah, the TFLite model should first be added as an asset, and then you can use this. So again, this TFLite model will be running on top of the object detection and tracking model with MLKit. So what this means is you have limited customizability because, well, your model is running on top of another state-of-the-art pre-existing model. So you have a little bit less customizability, but still there are some great options you can go ahead to customize. I've shown a few examples over here. Let's take a look. So first off, I have a detector mode. So which is essentially saying the same thing. I want to do live image classification. That is, I want to be using the streaming mode. So that is what I've specified over here. I also have a classification confidence threshold. So I'm saying that my confidence threshold should be 80%. So you can work around, you can try working with different numbers over here for the confidence threshold and you will get a hang of it. But yeah, these are some of the options that you can customize a bit. So let's get to the part where we actually run the model, perform the inference. Again, don't get intimidated by the code. We'll take a look at each and every line of the code and you'll be able to understand it and put it to use for your own models too. I also would like to just make a note that You might see some syntax here similar to the previous example. So first off, let's take the inference part. I again process my image, which is essentially running my model. And then I have these three listeners, which are on failure listener, on success listener, and on complete listener. So what this is essentially telling me is, first off, I need to run my model, that process on the image. Once I do this, if my model failed in doing so, I write something to the debug log. So I have these three dots over here. There was some text over there. So I write something to the debug log saying, okay, this is the error. Once that's, if that's not the case, then my model might have succeeded. So once my model succeeds, what do I want to do? I want to maybe draw bounding box around the detected the detected item and show it to the user. So, well, how do I do that? I've just added some simple, I print out something on the graphics overlay. I draw out something on the graphics overlay and show it to the user. Once this is done, which is my model either failed or model either succeeded in doing so and showed the results to the user, I have a non-complete listener. So once all of this is complete, I'm simply closing the image proxy. Super simple code. A thing which I want you all to know over here is all of these are essentially tasks. So the on failure listener, the on success listener are essentially tasks. So they need to be attached for every single run you do. And again, that is pretty much what you need to do with MLKit and start using MLKit for your own models. Just a few lines of code, as you can see over here, and it's super easy. So, uh, so we talked a lot about what to do after TensorFlow Lite model, but let me talk a bit about how do you go about the TensorFlow Lite model. I'll not talk much about this since I'm running out of time, but you can build great models with TensorFlow Lite model maker. The TensorFlow Lite model maker was announced by the TensorFlow team just in 2020. And remember the rock, paper, scissors model we made, the rock, paper, scissors application we made. I should call that now. Uh, so the rock, paper, scissors model I made for the application was built using TensorFlow Lite model maker. So TensorFlow Lite model maker is super easy to get started with, allows you high performance, allows you to make high performance models and allows high customization too. Another place where you could find great models is TensorFlow Hub. TensorFlow Hub is essentially an open source repository of well documented state of the art models. So remember that food classification app we made? The food classification model was essentially taken from TensorFlow Hub. So give TensorFlow Hub a look. In most of the cases, you might just find the right model for your use case on TensorFlow Hub. And on TensorFlow Hub, you also have these cool filters saying, okay, I want models, I want TensorFlow Lite models only. I want models which can be run on mobile devices only, and so on. So it's pretty cool. Give it a look out. And what TensorFlow Hubs also allows you to do, which I love the most, is you get to use models from the community. So yeah, these are not just the only publishers on TensorFlow Hub, but these are the only publishers I could fit in a single slide. So yeah, you essentially get to use models from the community. I also have a couple of models on TensorFlow Hub. Feel free to give them a look. With that, enough of talking. Let's get to code and let's see live demos. So everything we talked about today is implemented in this GitHub repository for you. I made this GitHub repository specifically for this talk. It also has the source code which I used to create the TensorFlow Lite models. I would urge you to take a look at this GitHub repository. So if there's this one URL or one source you want to go back to after this talk is over, it should definitely be this GitHub repository. So maybe I'll give you a moment to note it down or take a screenshot. Maybe one of the organizers could also paste it in the chat. I'll just wait a moment so you can make a note of this GitHub repository. Let me also paste it in the chat. Yeah, here it is. Oh, thank you. So what I'll be doing now is I'm quickly switching my screens. So hang on with me for a moment. Okay, and here it is. I hope you can see my screen now. Um, so here is the GitHub repository I talked about. It has both of these apps we made today implemented right for you. And yeah, if you just want to try it out, I also have the APK versions of these applications in the repository. So let's say you just want to try it out on your mobile phone, directly download the APK and try out right away. So let's see the code itself. Okay, so here I am in Android Studio. I hope the font size is good enough for you to see. And I've also switched on the light mode, so you could see maybe you could maybe make better sense of it. Okay, so first off, note this is the function where I essentially want to take a look at this analyze function. What this does is essentially runs the model itself, gets me the inferences. So first off, uh, I want to instantiate my model. So my model was called RPS model.TFLite. Well, I can also show it over here. Let me do that. That would actually be better. I could show it over here, what my model looks like. Let's open up app. So I know you might not be able to see this very clearly, but I'll read it for you. No problems. So remember I had told you that it creates a directory called ML in the module. So there's this directory. If you can't read it clearly, the directory name, as I can see over here, is ML, and inside which I have RPS model.tflite, which is the model I use. So the model name was RPS model.tflite, and a class of the exact same name was created for me by the model binding plugin. So if I double click this, I can also see the model metadata over here. But yeah, let's get on to the, yeah. So here I'm simply instantiating the model. Then I need to convert my data into a format which I can use. So we had discussed about tensor image. I'll pass in the image proxy and convert it into a tensor image. So that's what I'm doing over here. Finally, it's time to actually make the inferences. So I'll use the dot process method, and I'll use that on tensor image. So I just made a variable over here, TF image, which has the image proxy converted into a tensor image, and I'll do the process on it, which will essentially give me the outputs. Then, as I said, you could do any processing step over here. It's an array, all up to you, all you can think of. But for simplicity and demo purposes, I'll be performing a descending sort over here, and I'll be taking the top few results to show to the user. Once that's done, I also want to show this to my user. So I'll simply be adding the output labels and the output scores, which I could display to the user. So let's actually move on to live demos. Let's see this in action. So what I would have loved to do is shown this on an emulator, but well, I could show it in a real mobile device itself. So why do it in an emulator? Let's see an example of this in a real mobile device. Okay, that's odd. Give me a second. I guess I'll just do a retry. Okay, yeah, it's live now. Yeah, you can most probably see my mobile screen onto you. So you might see some latency in what I am demoing now because, well, I'm live streaming to you all and also wirelessly showing my mobile screen to you all. So you might see some latency, but the real application has almost no visible latency. So I hope my keyboard can make a good background. Yeah, that's my keyboard. Great. Let's hope it's a good background. And let me put something in front of it. So a rock, that's a rock. And give me a moment to see the results over here. Okay, I see it's almost 70% sure that this is a rock. So I feel that's pretty cool what my model could do. So I'll switch back my screens, and you also kind of saw a live demonstration of how our app performed. So with that, um, that's all I had to talk about the machine learning model binding plugin, the new MLKit, how do you do machine learning in Android. So with that, I'm done. Done for the talk. And if there are any questions, and I have the time, I'm running a bit over time. So if there are any questions and I have time, I would love to take them. So I'll leave that up to the organizers.
Thank you, Rishit, for that enlightening talk and the details that you shared. So I thought the examples were, and I love how simple you made the beginning examples in TensorFlow Lite, so the viewers can actually just walk away and try them straight away without any complexity or difficulty. I also really got intrigued of trying that TensorFlow Hub. This is the first time for me to see that, so I will check it out personally. And the demo was also super. So thanks for sharing those. I've been looking at our question and answer section, and I haven't seen any exam questions up to now. And so I'll elicit, please ask your questions away. Rishit's here for the next few minutes. And if we don't get any questions, then we'll be ending our event, which has been very, very cool. So what's your takeaways, Rishit, in terms of this? What would you tell the audience? Where could they get started if they were new to this type of stuff?
Oh, yeah. So as I said, if there's one thing you want to refer back to after this talk, it will definitely be the GitHub repository. So so go to this GitHub repository, which I just shared. It has, so not only does it have the example which we talked about, so it has this pretty cool explanation I've worked on. It took me a lot of time to write it out, but see the README. It has pretty cool explanation. It explains each and every line of the code. So that's a really good way for you to get started. I explain each and every line of the code in brief. So you can definitely get a very good idea from them. And that's how I would also recommend you to start. As an example, if you want to do something more to this, so first take a look at TensorFlow Hub. Find a model at TensorFlow Hub which interests you. So when I went to TensorFlow Hub, I found the model food classification model which interested me, and I made a demo out to you and showed it to you. So find a model which interests you, use everything that we talked about, and simply make an application for that model. So that would be wonderful for you to get started with.
It's excellent advice, and I totally think as well that that's the best way to go. There's so much out there on the web that sometimes we're not sure where to look, and this sounds very simple. Thanks for sharing those feedbacks and input and recommendations. And I'd like to close today, given we don't have any questions from our audience. One note to let you go, don't miss our iOS application development workshop that's going to be Monday night at 7. There you'll find Midhat Suleimani, who's going to run a hands-on interactive code lab, and you won't want to miss that one. Also, I'll share the GDG Slack link and YouTube again in the chat. We have an active Slack channel basically, just to get people to network a little bit more, we share. Let me post you. Cool. Thanks for joining and have a great evening to everyone. Thanks, Rishit.
Thank you. Thank you. If you have any more questions, feel free to catch me on any social media and simply ask it out.
Yep, I've posted them for the audience, so they should have got them.
Oh, thank you.